Hi, what you doing?
I'm reading a science book.
A science book?
Yes, and it's very funny. You should read it. It's called Tokens in Wonderland, and the chapter, The Guide Drive of Electrons, explains how the sodium chloride, the common salt, is formed. Mr. Tokens means that he is the valence electron in a sodium atom and jumps into the valence cell of an atom of current to fill up the cell.
That's a funny way to explain the thing we studied in class.
Yes, the sodium transfers its valence electron to the chlorine atom. In this way, sodium ions and chlorine ions are formed. Both with the octet complete and electrostatic forces hold them together. The relative size of ions causes each ion to be surrounded by 6 oppositely charged ions. An ion crystal is formed whose structure is face-centered cubic with coordination number 6.
In our project about the crystallization of sodium chloride, the first thing we have done is to determine the solubility curve of salt. We have to measure the amount of grams of sodium chloride that can be dissolved in 100 grams of distilled water at a particular temperature. Although the solubility depends on several factors, in the case of sodium chloride the temperature is not an important factor as we can appreciate in the solubility curve. Our crystallization work has aimed to obtain 3 types of salt: flour of salt, Maldan salt and cubic salt crystals.
The flour of salt is a type of salt that is characterized by its shape, small flakes whose structure is similar to the petals of a flower. It's crystallized from a saturated sodium chloride solution at high temperature, close to boiling point. It's filtered onto a crystallizing dish, which should be at room temperature, so that the thermal shock causes a very thin layer of salt on the surface to be formed. Maldan salt crystals are pyramid-shaped, but hollow inside. They are pyramids without the base side. They are named after the English town where they come from. It's crystallized from a saturated sodium chloride solution, which is kept at a constant temperature of 80 degrees centigrade. A layer of crystals is formed on the surface, and below them, salt gradually crystallizes, forming pyramids.
The flour of salt crystals and the Maldan salt crystals are both face-centered cubic systems, but the shape of the crystals doesn't give us the hint of that. Now we want to get the cubic crystals to be as large as possible. It's necessary to make the ions join together so that the crystal gradually grows. In order to get good cubic salt crystals, we must be careful with the crystallization conditions. We shall prepare a saturated sodium chloride solution at 45 degrees centigrade. We filter it onto a crystallizing dish and leave it stand in an isolated place. As the temperature slowly decreases, the solution gets oversaturated and we can see cubic crystals growing up at the bottom. In some crystals, a white cross is formed inside. That is water of crystallization.
After this work, we can conclude that the sodium chloride, also known as table salt or common salt, is not as common as its name says.